بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الجبر، وهو بعنوان الصورة المثلثية للعدد المركب. طبعا الأعداد دي مهم جدا جدا في حياتنا اليومية، بنستخدمها كتير في دراستنا وبنستخدمها كثير جدا في حياتنا. العدد المركب هو اسمه مركب لأنه يتكون من جزئين، جزء حقيقي وجزء تخيلي. وطبعا احنا عارفين ان في اعداد تخيلية، وطبعا الاعداد التخيلية دي اكتشفت بعد مشاكل كتير جدا في الاعداد. طبعا الاعداد الناتشرال نمبر اللي هي بتبدأ من 0 1 2 3 تو انفينيتي، بعد كده اكتشفوا الاعداد الصحيحة اللي هي البوزيتيف مع النيجاتيف مع الزيرو. افتر ذات اكتشفوا اعداد تانية، كل ما يلاقوا في مشكله بيكتشفوا اعداد كتيره، وهي دي بالاعداد دي مهمه جدا جدا لان بتحل مشاكل كتير في حياتنا اليوميه. الى ان تطرقوا الى الاعداد المركبه، ودي جت بعد الاعداد الحقيقيه. طبعا الاعداد الحقيقيه اللي اسمها ريل نمبرز طبعا ما كانش فيها سكوير روت لنيجاتيف، فاكتشفوا موضوع جديد اللي هو اسمه الكومبلكس نمبر، وهناخد درس النهارده اسمه الصورة المثلثية للعدد المركب. Welcome my dear student in our math program for secondary 3. Today we are taking a new lesson in algebra. It's titled Trigonometric form of complex number. My dear student, look at introduction about complex number. Trigonometric form of complex number. My dear student, at the first, polar and Cartesian coordinates. The opposite figure represents a circle with radius length r. A point xy lie on a circle and opposite to an angle of measure theta. Look at my dear student. Cosine theta equals adjacent over hypotenuse x over r. Sin theta opposite over hypotenuse y over r. Then by using cross multiplication we find x equals r cosine theta, also y equal r sin theta. My dear student, remember r equals x squared plus y squared under square root, also tan theta equals y over x. My dear student, theta equals shift tan y over x. If we modulate the Cartesian plane as polar plane, where the polar axis coincides on the positive part of x-axis, we can change polar coordinate to Cartesian and vice versa. My dear student, convert polar coordinates to Cartesian coordinates. Look at if we have point A in polar coordinates, A r theta, then the Cartesian coordinate of A, where x equal r cosine theta, y equals r sin theta, then xy equal r cosine theta, r sin theta. Remember, x equal r cosine theta, y equal r sin theta. Operations on set of complex number. My dear student, let z1 complex number its form x1 plus I y1. Therefore, we have z2 another complex number equal x2 plus I y2. Therefore, z1 equal z2. We deduce that x1 equal x2, also y1 equals y2. We have two complex number z1 z2. z1 equals z2, or two complex number r equals f real equal real and imagine equal imagine. Example, if we have x plus 3i equals 4 minus yi, therefore x equal 4, y equal negative 3, real equal real, imagine equal imagine. z1 plus z2, we add real plus real, x1 plus x2, and y1 plus y2 inside bracket multiply I. Therefore, we deduce an example if z1 equals 3 plus 2i, Z2 equals 3 plus I. When we add Z1 plus Z2, we add 3 plus 3 equals 6, 2 plus 3 equals 5. Z1, Z2, we multiply the first x1 plus iy1, first complex number, multiply second complex number, x2 plus iy2. We have more method. It's form x1, x2. Therefore, we translate to another example. If we have first complex number 5 plus 2i, z2 3 plus 4i, what is the multiply between z1, z2? z1, z2 is first complex multiply second complex. 5 times 3, 15. 2i times 4i equals 8i squared, negative 8. Then 2 means 6i. 2 extremes, 20i. We add 6i plus 20i equals 34i. Therefore, answer is 7 plus 26i. Or z1, z2, we multiply by using other method. Then answer is 7 plus 26i. Then we can find 5, multiply the second order pair. 5 times 3 plus 4i equal 15 plus 20i. And then multiply or distribute it to I among the second complex number 3 plus 4i equal 6i negative positive 8i squared. Remember, I squared change the sign of 8 equals negative 8. Why? Because I squared equals negative 1. Answer 15 minus 8 equals 7 plus 26i. Then Z1, Z2, its result is 7 plus 26i. Now we are translate to conjugate of the complex number z is z bar. Its symbol z bar. If z complex number x plus yi, then what is the conjugate z bar? X minus yi. Change the sign of imagine. What is the properties of conjugate value? These properties is very important. Notes. If we add any complex plus its conjugate, the number is real number. Example, z is 3 minus 4i, therefore its complex is 3 plus 4i. When we add 3 minus 4i plus 3 plus 4i, 3 plus 3 equals 6. Therefore, z1 plus z2 bar equals what? 3, or z1 plus z bar equals 3 minus 4i plus 3 plus 4i, negative 4i plus 4i equals 0. Answer is 6, is real. Then when we add any complex by conjugate, the answer is real number. Also, when we multiply any number, multiply its conjugate is a real number. Look at the example to clear the previous notes. If we have z equals 2 plus I, what is the conjugate? 2 minus I. When multiply 2 plus I, multiply 2 minus I. Then we find first times first, second times second. 2 times 2, 4. I times negative I squared. Negative I squared equals positive 1. Answer is 4 minus I squared. 4 minus negative 1 equals 5. Belongs also to R, real number. Look at the second or the third properties. Conjugate of adding of two complex equal adding of two complex number. Remember again, complex, we have two complex number. If we find conjugate of addition of two complex number equals addition of two conjugate of this number. Conjugate of z1 plus z2 equals conjugate of z1 plus conjugate of z2. Look at example. z1 2 plus 3i, z2 1 minus 2 1 minus I. When we add z1 plus z2. 2 plus 1, 3. 3i minus I, 2i. Answer is 3 plus 2i. This is add of two complex number. The result is 3 plus 2i. What is the conjugate of 3 plus 2i? Excellent, 3 minus 2i. Therefore, conjugate of addition, 3 minus 2i. This is the first equation. Since conjugate of z1, look at z1 conjugate plus conjugate of z2, also the same number, 3 minus 2i. From 1 and 2, from 1 and 2 we get conjugate of complex, add of two complex equal add of two conjugate. When find the conjugate of multiply by two complex equals conjugate of the first times conjugate of the second. Example, z1 equals 1 plus I, z2 3 plus 2i. Therefore, z1 dot z2 1 plus I inside bracket multiply 3 plus 2i. First times first 3, second times second negative 2, 3 negative 2 1, 3i plus 2i 5i. Answer is 1 plus 5i. Therefore, my dear student, conjugate of product of two complex equals 1 minus 5i. This is equation 1. After that, we find the conjugate of z1 times conjugate of z2. Conjugate z1, 1 minus I. Conjugate z2, 3 minus 2i. z1 conjugate or conjugate z1 times conjugate z2 equals 1 minus I multiply 3 minus 2i equals the same 1 minus 5i. From 1 and 2 we deduce that conjugate of product equals product of two conjugate. If z1 equals z2, what you deduce? Conjugate equals conjugate. Z equals z1 dot z2 or times, therefore conjugate of z equal conjugate of z1 times conjugate of z2. If z equals z1 over z2, we reduce that conjugate of z equal conjugate of z1 over conjugate of z2. Now we are translate to solve problems. My dear student, simplify I power 20 plus I power 25 plus 2I power 3 plus I power 35. My dear student, what is I? I is imaginary number. Imagine its first letter is I. It's called imaginary number. What is the imaginary number? Imaginary number, my dear student, we get it from x squared plus 1 equals 0. When we solve x squared plus 1 equals 0 in real number, answer is 5. But x squared plus 1 equals 0 in complex number, x squared equals negative 1. And we deduce that x equal positive or negative square root negative 1. And we agree about it. Square root negative 1 is called imaginary number is I. We have 4 bases of imaginary number. I square, I power 3, I power 4. What is I? My dear student, square root negative 1. Negative 1 has a square root? Yes, in complex number. But in real, has no root. Square root negative 1 doesn't belong to real numbers, doesn't belong to R. But square root negative 1 belongs to complex number, its symbol I. I square equal negative 1. I power 3 is negative I. I power 4 equals 1. Then the important family of I power 5, I power 9, I power 13, increase 4. power increases 4. I power 2 also has family. I power 2, its family I power 6, I power 10, I power 14, I power 18, I power 22, and so on. It equals negative 1. I power 3, its family increase 4, I power 7, I power 11, I power 15, I power 19 equals I power 3 equals negative I. But I power 4 is very important family. I power 4, I power 8, I power 12, I power 16, I power 20, I power 24, to so on. It's equals 1. Then, if we have I power 20, 20 divided by 4, yes, answer is 1. But if we have I power 21, what is the value? I power 21 equals I power 20 times I power 1 equals I power 1. Also, I power 22. We divided 22 into 20 plus 2. Its power 20 plus 2 equals I power 20 times I power 2. Therefore, I power 20 equals 1. I power 2 equals negative 1. Then, I power 22 even divisible by 2 equals negative 1. And we can make summary any even number divisible by 4 equals what? Equals 1. Any even number divisible by 2 equals what? Negative 1. My dear student, look at the solution of this example. Look at, my dear student, I power 20 equals 1. Why? Because 20 divisible by 4. I power 25 equals I. Why? Because I power 25 equals I power 24 times I power 1 equals I. I power 3 equals I power 28 times I power 2. Then is I power 2. I power 2 equals negative 1. I power 35 equals what? Equals negative I. Why? Because I power 35 equals I power 32 times I power 3. I power 3 equals negative I. When we add 1 plus I, negative 1, negative I, answer is 0. Another example. Simplify 1 plus I plus 3 over I power 3 plus 5 over I power 5 plus 7 over I power 7. Remember, my dear student, what is the definition of 1 over I? Equals I power negative 1. Also 3 over I power 3, 3I power negative 3. 5 over I power 5, 5I power negative 5. 7 over I power 7 equals 7I power negative 7. Look at, we complete I power negative 1 is I power 3. Also I power negative 3 is I power negative 5 is I power 3. I power negative 7 is I. Why? Look at, my dear student, if the power is negative 1, we add 4, I power 4. I power 4 times I power negative 1 equal I power 3. Also, why I power negative 3 in second term? We multiply it by I power 4. I power 4 equals 1. I power negative 3 times I power 4 equals I power 1. Also, I power negative 5 multiply I power 4 equal I power negative 5 plus 8. We multiply I power 8. Why 8 divisible by 4? Negative 8 plus 8 equals 3. Also, negative 7, I power negative 7, we multiply it by I power 8. I power 8 equals 1. Why? Because it's multiples of I power 4. Then I power 3 is equal to what? Negative I. I power 3 also 5, I power 3 negative 5I. We add negative I plus 3I, negative 5I plus 7I. Answer is 4I. Expand 2 plus I for all power 4. You can expand 2 plus I for all power 4? No. What you do? We can expand 2 minus I for all power 2 for all power 2. Look at the solution. we can put 2 minus I for all power 2 for all power 2. 2 minus I for all power 2, first power 2, second power 2, first times second times 2. 2 times 2, 4. Negative I power 2, I power 2, negative 1. Also 2 times negative I times 2 equal negative 4I. Answer is 4 minus 4I plus I square for all power 2. Therefore, 4 plus I square equal negative 1. 3 minus 4I for all power 2. And repeat the method. 3 power 2, first power 2, 3 power 2, 9. Second power 2, 16I square. First times second times 2, negative 24I. Then add I square, 16I square plus 4, y plus 9. Why? Because 16I square equal negative 16. 9, negative 24I, negative 16. Answer is negative 7, negative 24I. Find in the form a plus bi, z equals 3 minus 7i over 5 minus 2i. Look at the solution. We use conjugate. Look at complex number in numerator 7 minus 7i, 3 minus 7i, in denominator 5 minus 2i. By its conjugate of its denominator 5 plus 2i up and down. We multiply 5 plus 2i up and 5 plus 2i down. Look at, we have two complex number in numerator and two complex number in denominator, but in the denominator we find first times first, second times second. Why? It's conjugate. Its product equals real numbers. 5 times 5, 25. Negative 2i times 2i, negative 4i squared, or equals positive 4. 25 plus 4 equal to 9. Then answer is 15 plus 6i minus 35i, negative 14i squared, over, look at the second in denominator, 25 plus 4, 29. Then the z becomes z in 29 minus 29i over 29. We can take 29 in numerator, highest common factor, by using common factor 29 over 29 minus 29 over 29i. What is the z? Became z equals 1 minus I. Look at, my dear student, if we have z 7 minus I over 2 minus I, find conjugate of z. As the first, my dear student, we can find the complex number by using multiply conjugate of its denominator 2 minus I is 2 plus I up and down. After that, we find conjugate of z. Look at, my dear student, z equals 7 minus I over 2 minus I multiply 2 plus I up and down. Therefore, the denominator becomes 2 times 2, 4, negative I times I, negative I squared. Therefore, z equals 14 plus 5i plus 1 over 4 plus 1. Z is 15 plus 5i over 5. By using 5 common, or divided 15 over 5 and 5 over 5, or take 5 common in numerator and we simplify 5 with 5 divided by 5 each denominator. Answer is 3 plus I. What is the conjugate of z? 3 minus I. Then at the first, we find, or we simplest form of z complex number by using multiply of conjugate of its denominator up and down, and we find conjugate of the result. The result is complex number z, 3 plus I, then conjugate is 3 minus I. My dear student, if we have z equals 1 plus 4i plus 3i squared negative 7i power 3 over 4 plus 7i plus 3i squared plus 5i power 3. Find z bar for all power 2. At the first, we simplest form of the complex number 1 minus 4i minus 3 plus 7i over 4 plus 7i minus 3 minus 5i. Look at, we find the like terms in numerator and denominator. 1 minus 3 equals negative 2. 4i plus 7i, 11i. In denominator 4 minus 3, 1. 7i minus 5i, 2i. Then z became negative 2 plus 11i over 1 plus 2i. By using conjugate of its denominator, multiply by 1 minus 2i up and down. Therefore, we multiply by conjugate of denominator 1 minus 2i up and down. Then the z became, my dear student, in denominator 1 times 1, 1, negative 4i squared. Remember, I squared equals what? Negative 1. Also in numerator, negative 4 plus 4i plus 11i minus 22i squared. Therefore, z became negative 2 plus 15i plus 22 over 1 plus 4. Answer, my dear student, z equals 20 plus 15i over 5. By using 5 common denominator in numerator, then z by using divided by 5, z equals 4 plus 3i. After that, we find conjugate of z, 4 minus 3i, it's a conjugate of 4 plus 3i. Remember, my dear student, conjugate, we change or convert the symbol of imagined number. 4 plus 3i, it's a conjugate 4 minus 3i. Therefore, conjugate square equal 4 minus 3i square. First power 2, second power 2, first times second times 2. First power 2, 16. Second power 2, 9i square. First times second times 2, negative 24i. Remember, I square change positive to negative. Then 16 minus 9 equals 17 minus 24i. This is answer of square of conjugate of z. My dear student, by the end of the lesson, we know complex number, and we know that complex number is very important. We know complex and its conjugate. This lesson very important to use it in the next lessons in algebra and solid geometry. My dear student, I am very happy to spend such time with you. Thank you. Good.